All right, cool. We are ready to go. I'm just kind of doing a final system check, making sure that the stream is up and running and everything's looking okay. Okay, cool. All right, so welcome to Study Hall. This is an opportunity for you all to come in and ask questions. If you've got questions from Learn, feel free to just post any questions or any topics that you want to have me cover. If you have any code you want me to troubleshoot, feel free to just throw it in the Slack thread so it's formatted. If you're pasting in code that you want me to troubleshoot, do make sure that it's formatted. Otherwise, I'll have to assume however you formatted it, which a lot of times if the formatting is the issue, then it can get lost in translation if you don't put it in a formatted code cell. So just make sure you do the triple backticks so that it shows up in monospace and I can copy paste it easily. Other than that, if you have a question from Learn, just paste in a link with like any notes on whatever the question is, or if you have any code that you want me to troubleshoot to, just like I said, and I'll be happy to go through it. So. Let me just get my environment up and running here. Didn't do sanity check. Okay. There we go. Okay. So I thought I'd do another Code Wars stream today. You can see I've got Code Wars up here. Oops. And let's see. I just figured I'd pick a couple problems kind of at random and just go through them, talk about problem solving approaches, show how I like lay out tests before I get into a problem and things like that. And yeah, we'll just go from there. Let me put that down there. So I just wanted to show this part. So again, quick note on if you're new to using Code Wars, when you come in to use Code Wars, there's this bar on the left. I think it'll take you to the dashboard by default. I think this is the home page that it shows you. But I always come to Kata, the little magnifying glass. I come to Kata right here, and then here I just look for random problems. And the thing to know here, you can just kind of do what you want with these settings or leave them alone. The one thing that's important, obviously, you got to select the language that you want to find a challenge in. When you set up your Code Wars account, it's probably kind of associated with Python if you set it up to be that way. There's sort of a My Languages section. So let's see. I've got a few languages that I have this set up with, so let's just find Python. See if I can find it. Okay, there it is. So we'll make sure we're only getting Python problems. And then you have your difficulty selection here. Now this could be a little bit counterintuitive. When I first started, I was trying to do the level 1s and 2s because I thought, oh, those are going to be the easiest. These are the hardest, and they are extremely hard. They're very, very challenging problems. So if you're trying the 1s and 2s and you're like, oh, I'm not sure I can do this, it's not you. It's the problems are very hard. So 8s and 7s are very easy, very beginner focused. So I'm going to just, you can select multiple difficulty problems to look for by just dragging. So if I wanted to do if I wanted to find a 7 through a 4, I could just drag my mouse, click on 7, and then just drag it until I find wherever I want to be. But I'll do 8s through 6s, and we'll just do some easy ones. 6s kind of start getting into something kind of interesting and challenging, but Okay, cool. So that's just something to know up front if you want to start using Code Wars. That's how I like to use it, at least. Cool. So now I'm just going to look through here and just find a problem that maybe looks interesting. Small enough beginner. We've got tank truck. That could be interesting. Largest pair sum in array. Oh, that could be kind of neat. I'm just opening these in new tabs to kind of look at them later. Let's just go with this largest pair sum in array. So that'll bring us here, and then you'll just come up here where it says train, and you can look through it and kind of, I don't know, see similar problems or whatever. We'll come up to here to train, and then I've kind of got the, well, here, let me, I'll have this cut off again so it doesn't get like overlay my text editor, but on the left-hand side, you've got your problem statement, and you can see we've just got a very simple problem statement. Most problem statements will be longer. They'll have more copy than this. And then, of course, it gave it to me in JavaScript for some reason, so let's come to Python. Okay, so we've got Python 3.8. Yep, that's what we want, 3.8. And you've got your solution code here, and then some sample tests down here. So on the left-hand side, like I said, you've got the instructions, and when you run this, when you run your solution code, it will run it against the sample tests if I click the test button, or it'll run it against a bunch more tests behind the scenes that we don't have privilege to access. We can't see those tests if I hit attempt. So if I hit attempt, it'll run it against some other tests, and it'll be like an actual attempt. Yeah, and then once that runs, you'll see the output in this output area over here. So what I like to do and what I recommend people do, just copy the problem statement into Replit or whatever your environment that you're comfortable with. Just whatever you do, basically, don't work out of the actual Code Wars REPL. It's not that great, and I feel like I don't have the kind of control over it that I would with a regular REPL, like my editor that I'm used to, or like VS Code, or Replit, or even Jupyter Notebook or something like that. So I recommend just pick whatever environment you're comfortable with and copy and paste everything in there. Do all your work in there, and I'll kind of show you how to get set up with that. So you could copy paste this part, but I actually recommend typing it out. Even if you just type it out just as you see it, something about like the action of actually pressing the keys to type the thing, I think helps ingrain the like doing the work of solving the problem. I can't really overstate the importance of that. I know it seems trivial, like, well, it's right there. I could just Control C, Control V, copy paste it into my editor, but I do recommend typing it out. Might seem like a little thing, but I think it's important. And then the other thing here is I'm going to look for anything that I can turn into a test, right? So what do I mean by that? So something that I can turn into a test, all I need to know for a test, for any problem, and I haven't even read this problem statement yet, but for any problem, all I'm looking for is something of a given structure to build a test out of. So all I need to see is some input into the function, the result of that function, and the expectation that we have for that function given that input, right? So what this looks like, and I'll do these in variables because I kind of like to do it this way. what this looks like is something like this, right? I can look at this a lot of times when you see for example, that's probably going to give you all the elements of a test, right? So this doesn't give me the result. Obviously, my code will give me the result. So really, a test just needs to have an input and say, so for this input, we would expect this specific output. And this sort of text arrow thing is universally understood across languages as sort of like, you know, given this, you'll return this. You'll have this as an output. So that's sort of a shorthand for return. Okay, cool. So let's get into this. So what this is saying is for this input, if I put this input into my function, I'm going to expect this output, it looks like. And obviously this is not, I think this is not quite right. Well, we'll kind of get into that in a second here. But so basically all I'm going to do is just write some tests to start off with, and then we'll actually get into the problem solving. Give me 1 second, folks. Apologies. Okay. Cool. So back to this bit here. So I'm going to follow my own advice here, and definitely if you're a beginner, definitely write this function head out. Don't just copy and paste it. Actually write it out. So we'll write it out by hand. Def largest pair sum. We'll take in numbers. Sometimes it matters in the tests that the parameter has the same name as is shown or as is given. So I always just keep it the same. A lot of times you can get away with changing it, and you know, I'd probably call this in or num. It's sort of my own preference for naming convention. Maybe nums since it's plural. So I don't know, but I'll keep it as numbers for now. Okay, so this other stuff is just kind of filler. It's not doing anything right now. So, all right. Now I'll put in this pass just so we have something, and now we'll sort of look at what this is asking. So, given a sequence of numbers, looks like it takes in a list of numbers. Find the largest pair sum. Find the largest pair sum in the sequence. Okay. Sorry, I was thinking this is the function name. I was like, this is weird. Okay. Anyways, it's just me being dyslexic. Find the largest pair sum in the sequence. So for this one, I think it's saying 42, and then it's just giving us a little explanation. 23 plus 19 is 42. Is that right? Yeah, that sounds right. So 20 plus 10 is 30, plus 9 is 39, plus 3 is 42. Okay, cool. And then if we look here, 23 and 19 are the largest pair sum. Okay, cool. So it looks like we just want to, let's read this. Input sequence contains minimum 2 elements, and every element is an integer. Okay, great. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. And it looks like, oh, that's interesting. So this test is actually wrong. It's saying for this we expect. Oh wait, I see. So when it said pair, I was thinking that the numbers had to be contiguous. They had to be next to each other. But given this test, I was thinking, oh, this test is miswritten because 99 plus 23 is 122, but 99 and 23 are next to each other. But given this example, this tells me that probably this is intentional, and I can deduce that because it looks like there are 3,049 people out of 4,566 people who have solved this problem. So given that it has that many solves, an issue like that would have been reported and ironed out by now. So it has, this problem has quite a number of solves, so it's probably accurate. Even though it maybe could be a little more descriptive, it's at least probably accurate. So that tells me kind of how this works, and this is actually a good example of why I write my tests first, because in order to write the tests, it makes me think about how this problem has to work. And in this case, I'm just looking at tests that are already given. But yeah, okay. So let's write this first test. We'll take an imp, and we'll do this. We'll say print res equals exp, and we'll print res as well. And now the nice thing is I've got this nice little function that'll test my, or nice little bit of code that'll test my function. And I actually could write this as a function, but I'm not gonna. Okay, so let's just do this. We'll make another one, just copy paste it like that. And this time we'll use this list, oops. And we'll say that our expectation is 120, and that's all we have to do. We just have to change the input and the expectation. We don't need the comment there, but I'll put it in just because that's what it's saying. Cool. So every time we write a new test with this little setup, we just kind of copy it, and I've got a line duplicate shortcut, and then we'll just change the input and change the expectation for that input to match, and everything's already wired up. Cool. Okay, so that's how we can turn these examples into tests, and you can see like I said, all that's here is just like, for this input, we expect it to return this output, right? And this isn't even written as code. This is just saying, for an input, we expect this output. That's all. That's literally all it's saying. So, yeah, it's pretty easy for me to just grab that and turn it into a test. Now, if we come back to the Code Wars area here, what I like to do is we'll just copy all the stuff in the tests here, and we're going to kind of chop it up. I'm just going to make these little bars so I know just visually it's easier to discern where the thing I'm pasting in is. Okay, so this might look a little bit intimidating, but we're going to turn it into stuff we're familiar with. So I don't really care about anything that doesn't obviously have a call to the function with some input and some output associated with it. So we're just going to kind of start deleting stuff until we're down to only those lines. These test.assert equals, these are methods that will test our functions here. But basically, all that I'm interested in here is the inputs and let's see if I can do this. Alas. We'll get this one here, and you'll see why I'm doing it this way in the outputs. Okay, so I've got my inputs, my outputs, and I don't even need these calls here. I'll just get rid of those. Okay, so from here I can say imp equals this, exp equals this. Res equals function name. Ah, that didn't work. Okay. Okay, let's do that. Res equals that. And then each of these gets a print after exp. Of course, you don't have to lay it out in this order. You could do input, expectation, result, or whatever. Doesn't matter, but I'm just going to keep them consistent. Okay, cool. So we've got a whole bunch of tests. And it's always a good idea, especially when you're like using somebody else's tests, to kind of give them just a quick look. For example, I see like this one I think is exactly the same as my first one up here. 10, 14, 2, 23, 19, and our expectation is 42. Here we've got 10, 14, 2, 23, 19, so this one's the same. We can just get rid of that. Looks like the largest sum we can expect from this one is 0, and that's because we've got negative 19 and 19. Now these two are contiguous. They are next to each other. Oops. And I just realized, see, here's another good reason why. I just realized that I didn't totally delete. There's a little artifact, that little parenthesis and comma, so I didn't totally clean that up. That's okay. Okay. So negative 19 and 19 is, of course, 0, and I'm just going to format these just because I like it. Okay, so let's look through here. I imagine it's going to be 10. Yep, it's going to be 10 because 6 and 4 are the two biggest numbers. And then negative 18 is the largest sum. That's interesting. And I guess if we look at the two smallest numbers, which are 8 and 10, those added together are going to be negative 18, or negative 10 and negative 8, excuse me, are going to be negative 18. Okay, cool. So that makes sense. So one thing I do notice is that in all these tests, the numbers, the two largest numbers, or the numbers that sum in the answers, actually are all next to each other. So that actually kind of makes me think maybe this test is broken. It would be conceivable. I've seen weirder on Code Wars, but this is just something to note. You know, it doesn't mean we have to be like, oh, you know, this problem is broken or whatever. But it's just something to keep in mind. And it's not. This is kind of a cool thing actually, because a lot of times when you're testing something, you kind of deal with some uncertainty, and that's okay, right? Because as long as we remember that point of uncertainty, we can come back and accommodate it when we need to. So, you know, I'll write this up with one assumption, noting that I am making an assumption, and then I'll submit it. If it doesn't work, then I'll try the other assumption, and we'll go from there. Cool. So first assumption that I'm making is going to be that numbers in, quote, pairs do not need to be contiguous. I'm not sure if that's how that's spelled, but I'm going with it. Okay. The other assumption that we could make is that they do need to be contiguous, but I'm going to start off with this, and like I said, if it doesn't work, then we kind of have a place to look at, right? We have a potentially known failure point. Okay, cool. So we'll build it with this assumption and then go from there. So how should we start this one? Let's see. What we're going to return, let's start with our return and kind of work backwards from there. So since we have a list of numbers, we're going to need to write a for loop to iterate through that list. Excuse me here. Write a little for loop to iterate through that list. And let's pass in here for now. And I'm going to return an accumulator. And I'll say accumulator equals 0. And now basically, since the numbers in pairs do not need to be contiguous, what this means is I have to structure this problem in such a way where I compare everything to everything else, right? So I need to see the sum of 10 plus 14, 10 and 2, 10 and 23, 10 and 19, and then I'll move on to 14. We'll do 14 and 10, 2 and, or excuse me, 14 and 10, 14 and 14. I guess we don't want to compare it to itself. 14 and 2, 14 and 23, 14 and 19. So we've got to do this thing where we compare everything in the list to everything else in the list. I'm going to assume that since this is such an easy problem, that we just don't even need to think about like what happens if we compare a number to itself. I'm going to assume that the tests are written in a way that we can do that and it's going to be okay. Even though I think that would break the terms kind of set out by this, right? 14 and 14 in this list is not a pair of numbers. It's the same number, right? But we'll just kind of go with that. Or actually, no, that won't work because, yeah, we'll need to make sure that we're not actually adding a number to itself, of course. Excuse me. Okay, cool. So whenever I have a problem and I think I've got to compare everything in this list to everything else in this list, I know right away that I need a nested for loop, or that I can solve this problem with a nested for loop. So we'll say num1 and num2, and in this case, both loops are going to be iterating through the same sorts. They're going to be both iterating through numbers. It feels a little weird to do that, but it's totally fine, and there's a number of problems that I've solved that are structured with loops exactly this way. So, okay, so for num1 in numbers, for num2 in numbers, we're going to, now we just need to make sure that the numbers are not the same, so I'll just say if num1 is not equal to num2, let's do that. So this will make sure that any two numbers that are the same won't be added together. But actually, I'm looking at this here, right? Like, what if we had, and this is another great reason to have tests, right? So I could say I just kind of thought of another test. And I encourage you to do this when you think, oh, what about this certain scenario? You have that thought like, what if I encounter some specific scenario? Write a test for it, right? So let's write a test for this scenario that I just thought of. So here, what if I have two of the same number, and the largest, and those numbers actually make the largest sum, right? So I would say that this would be a valid pair. I would think it would be. Anyways, I'm not sure that, I mean, we're not rich with description and copy for this problem, so I'm left guessing a little bit, but I think I'm going to just make that assumption that if a number occurs twice, it can be considered a pair, and let's just note that assumption here. So actually I'll just do if a number occurs twice if, let's say, if the same number occurs twice, it can be in a pair with itself. Oh, I don't know. I think there is an apostrophe in there. Woof. Okay. So one thing that I notice here is I believe we've actually got to accumulate all. Yeah, we've got to accumulate all the possible sums into a list here, and then we'll just return the max of that list. That's all we've got to do. Since I just sort of built in this new term, and it's an assumption, and I know it's an assumption. I've notated it, and this is another thing. Like if I submit it and it fails, these assumptions are places that I'm going to look first, basically, aside from like just syntax problems or whatever. So since I did this, if we look, what I really need is to be able to, like, I don't want to compare 14 to 14, but I do want to compare 23 to 23. It doesn't matter if I compare this 23 to itself and this 23 to itself and or either of these 23s to each other, right? I'm going to get the same sum anyways, so who cares, right? So, but I do want to avoid comparing a number to itself if it's the only one in the list. So I think what I want to do here, I could do like a count, like if the count of the number, I could take the count into consideration, like if the number occurs more than once, then it's okay to compare it to itself. But I think instead what I'm going to do is compare only to different indices, right? So if the number is at a different index, I will compare. When I say compare, I just mean add. That's sort of a term that I kind of use kind of loosely. Compare meaning to add or do some operation. But that is how I think about it, right? Like I need to do some comparison. In this case, it's an addition, right? Some way of combining these numbers together, right? So what I want to do is just say, okay, if num1 and num2 have the same index, which at some point they will, then they're the same number, not only in value but in position. And it's actually that position that tells me not to do the comparison. So I think what I'm going to do is we'll enumerate. And the reason we're going to enumerate is the tool that we use when we want the indices of something. So we'll say IDX. These need different names. So we'll call this JDX. And this is sort of a convention to call something I and then call the next thing in the next nested loop to call it J. If you call something I, you call the next thing J. So this is just sort of a play on that tradition. Cool. So instead of num1 not equals num2, I'm actually going to do IDX versus JDX. So if IDX not equal to JDX, then we will acc.append num1 plus num2. Okay, cool. So looks like if I look at all these, we have all trues. So when this prints true, it means res equals exp is true, but I have one false, and that's actually because I wrote this test and I forgot to write in the expectation. And it's not because I was just like, oh, it's not important. It's just because I literally forgot. So 23 plus 23 is 40, plus 3 plus 3 is 6, so that's 46. So is that 46? Okay, so now I got all trues. And the trues tell me that it's passing. So I can just look at a glance and just see whether or not it's going to pass the test. In this case, they all appear to be passing. Now, they all are passing given that I made these assumptions. So we'll see if they actually pass the Code Wars tests as well. Because I don't know if the person who wrote this Code Wars challenge is making the same assumptions that I'm making. Quick note, like if you're going to write a Code Wars challenge, I believe it's your duty to make sure that any assumption like this is made clear in the copy, but that is not the case in a lot of problems just from around the internet. But yeah, so if you find yourself writing a Code Wars problem someday, just keep that in mind though. Okay, cool. So this does appear to be passing all my tests, and just the reason that I'm also printing out the results separately is if I get a failure at some point, I can see what the result was and then look at the expectation and see how it differs and then discern, okay, how did I get that? Since I know which result is wrong and I know what the result is, I can see what the result was exactly. Then I can see, okay, well, why did that happen in that particular case, right? And then I'll isolate it down to that one test. I'll comment out all the other ones and isolate it down to whichever test was failing. But in this case, the only test that was failing was because I just forgot to update the expectation. All right, cool. So that being said, looks like we've got a working solution here. I'm just going to go for attempt, and we'll see. Looks like my assumptions paid off. They were it's either that I needed to make those assumptions or that it didn't hurt to make those assumptions, but it worked either way. So looks like I passed all the tests and we can submit the code and we'll go see the other solutions. So if you want to do this on your own, here I'll actually kind of hide that. If you want to do this on your own, I'll let you go like look at the different solutions, but a lot of times you can see some pretty cool other solutions. Yeah. Cool. So that was, let's see, that was what? I think that was a level 7. That was kind of nice. It wasn't a particularly challenging problem. But it had a little bit going on. It had this nested loop, which is a bit of a trick. I look at this and I'm like, okay, if I do the compare everything to everything scenario, I know that that's just that style of nested loop, just because that's a scenario that happens enough that I just know to do that loop when I see it. So, yeah. And that's the thing. I think as you're learning to program, like look for those little things, like what do you do when you have to compare everything to everything else in a list? Do a little thinking about like what kind of situations you're encountering that might actually be common situations, and then kind of remember general form for those solutions. Okay, cool. Yeah. So let's move on. Let's do another one. Excuse me. And I wanted to go slow with that one and just kind of talk about like everything that I'm doing and kind of lay it out in the way that I'm thinking about it, and talk about why I'm making the decisions that I'm making, things like that. But yeah, I think in this case, I'll go a little faster and kind of try to pick things up a little bit. So let's find another one. I had somebody asking printer. So this says printer errors. So I wonder if this is going to be a little bit of an error handling thing. Oh, nope, doesn't look like it is. Had somebody asking about error handling. You don't tend to see too many things that well, you don't tend to see too many things that like explicitly require error handling anyways, but especially not in the sort of easier problems. Cool. Let's try a 6. Try my hand at this here, 6. So it looks like there's going to be a bit more going on with this. You can see we've got examples, and these are just tests. I'll just copy all those in a little bit. We'll start with the actual copy, though. Okay. And then just looking through here, it looks like, yeah, it looks like there's some tests in the actual testing that aren't present in the examples here, so we'll just grab all of this, just kind of clear it up as we get into it. Okay, so there's that. So those are our expectations. These are our results. And I can just keep these. I don't have to make a separate input variable. We'll just keep the inputs in there since that's easy. Okay, so we'll do this, and then excuse me, we'll do that. There we go, that's better. And I'll just say print res equals exp and res. Put some spaces in there just so it's not too cramped. And then let's see, so I see this 1, 2, 3, 4, and 0 has an expectation of an empty string. Empty string and 0. So I see some empty string tests here, and these are sort of maybe edge cases. So let's kind of just copy these. Here, I'll just do this just so I have a clear idea of where I'm working. Sometimes, you know, like you can be duplicating lines and it can be hard to see, okay, which ones am I working on? So I like to just, I think about it like traffic cones or something, you know, like this area under construction. I'll just put these up temporarily just so I, like this little fence, so I know, okay, I'm working inside that fence, you know, so that's why I'm doing that. You may not have the same problem. I am dyslexic, so mileage may vary. Okay. So looks like I can get rid of this. I'll get rid of that. It just has a random input variable here. Just put that right in there. Get rid of that variable, and we're just left with these four. So the question is, I don't see that number anywhere else, so looks like all of these are unique tests, so we'll incorporate them. Okay, so that's exp equals this, res equals this, that, get those commas out of there, and then we'll just do this print. There we go. Okay. So there's all our tests. I'll actually just leave those in the fence there so I kind of know where they are. Revrot, that's the name of this function. I haven't even, it's kind of funny, I haven't even like looked at anything about this function. We're just writing tests. I hope that kind of speaks to something as you watch me work through this. You know, you see how much energy I put into building up tests before I even read the problem statement. A lot of times, just looking at the tests, I have a pretty good idea of what I'm supposed to end up with. Not so much in this particular case, but a lot of times, the tests just explain what's supposed to happen. You can look at the input and say, oh, well, if that's my input and that's my output, I must have to do this certain thing, you know. So they end up being kind of part of the problem statement. So just good to spend some time, write some tests, and you'll get an idea. Now, in this case, I don't know how many tests. We've got a lot. We've got a whole lot here, but that's okay. You don't have to write a ton. I'm just copying them in because why not? It's Code Wars. They're all given there for me, so kind of might as well. And then yeah. Yeah, sorry, kind of lost my train of thought there. But the important thing is just write like at least one test. Anytime you're working on a problem, you don't have to go overkill like this, but just write at least one. And if there are some obvious edge cases or other scenarios, then it's worth writing them down if you think about them. But a lot of times, you know, the ideas for the tests aren't necessarily forthcoming. So just write in one, and then as you're working the problem, if you think of those other scenarios, you can always write another one. Cool. Writing the second one's easy if you have the first one right there. You just copy paste it. Okay, so let's actually read this. So this says the input is a string of digits. So that says string and size, I guess. So let's see. I'm going to call this DG, oops, for digit, DGT string, digitster. And then SZ is good for size. The input is a string of digits. Cut the string into chunks. See, this is it's kind of funny, right? The input, this function has two inputs, and the problem statement is like, the input, the one single input. Anyways, minor gripes. Okay. Cut the string into chunks. A chunk here is a substring of the initial string of size z. Ignore the last chunk if its size is less than z. Okay, interesting. So cut the string into chunks. A chunk here is a substring of the initial size. So I'm wondering, does that mean I've got to have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So I can see that, you know, the length of this is a multiple of 6. Yeah, that's very interesting. 1, 2, 3, 4, 5, 6, 9, 8, 7, 6, 5, 4, 9, 8, 7, 6, 5, 3. Okay. So it looks like these strings are identical except for the last number, but then the interesting. Yeah, so I'm just kind of looking through here. This is another reason to do the tests, right? Because they kind of tell the story. That's very, very interesting. Okay. So 9, 8, 7, 6, 5, 3. 1, 2, 3. Yeah, okay, this is going to be a tricky one. So if a chunk represents an integer, such as the sum of the cubes, I'm still not really clear on what a chunk is, but I'll come back up to that. So if a chunk represents an integer, such that the sum of the cubes of its digits is divisible by 2, reverse that chunk. Okay, so if the chunk otherwise rotate it to the left by 1. So we'll take the sum of the cubes of a chunk, and I'm guessing a chunk is some substring of size sz. So let's check this out. Okay, so a chunk here is a substring of the initial string of size SZ. Ignore the last chunk if its size is less than SC. So if we have some, if we have some length of the string that doesn't fit into the chunk, then we'll just drop it off. Okay, cool. So I see. So let's call this come on. So this will be chunk size. We'll call this chunk size. That'll help me think about it. So I think the first thing that I want to do here is I'm just going to make some variables here. So I think I just want to break the string into appropriate sizes. So I think what I want to do is just make a list of chunk-sized substrings, and yeah. So I could get the length of digit string. I hate this name. I thought I would like this name. Digitster. I don't like it. Whatever. So I get the length of this, and somehow I think like the length of this, I want to know how many chunks that I need to have, right? So the number of chunks is that a string would create is the length of the string, I think, over chunk size. And that's going to be an integer. I could do floor division there, but whatever, I'm going to do an integer. Okay, so if I divide it by that, I think maybe I can just do like a range through this. Range. We'll just say for I in range that. And just to kind of clarify this a little bit, let's call this, let's put this in a variable. Let's call this num chunks. It's because it's the number of the chunks, right? Or let's call it chunks count. It's the count of the chunks. Okay. Chunks count. Maybe chunk count. Okay. Chunk count. It's kind of funny. Okay, so for I in range chunk count, and then maybe we want to do for we will say list dot append, and then I just need the chunk. Interesting. Okay, so maybe I want to do 1 to this inclusive, and we'll say we'll append digit string sub. I'm going to just append a slice. Now I want to start at I want to start at initially, I want to start at 0. And then I want to go up to chunk count. So I'm going to do a slice here, so we'll start at nope, I'll back this off. That's nice. That's actually really handy. So we'll do chunk size. So I'll do I times chunk size. And when I is 0, that'll be 0. And we'll stop at chunk size. So I'm going to just kind of format this so it's very clear. All right, so there's our start, and there's our stop. And then maybe what I want to do here is actually I plus 1 plus 1. Yeah, I think that's what I want to do. Let's check in on this. I'm just going to return the list, and we're going to have, these are going to fail. They're not going to be true. Division by 0. Okay. Of course we can't do that. 0 division error. So that's very interesting. And it looks like this is happening on 71. And let's see which test. 107. We got to look at 107. Look at this. So we have chunk sizes of 0, 1, 2, 3, and I'm going to guess that in every case that we have a chunk size of 0, we're going to return an empty string. So let me just check this out. So this should do it. Okay, so that returns an empty string, empty string, empty string. Good. So I think what I'm going to do is just, well, looks like we're going to do some error handling. Anyways, I'll say try. Try this, and we'll accept on this 0 division error. And if we get that 0 division error, we'll just return empty string right away. Perfect. Okay, cool. So it looks like we got some passes. I'm going to assume the passes are for the empty strings for those right there. But let's just look at this. And my goal here is just to see if I have the correct numbers. I'm just going to go through. So I know they're not going to be in the correct order. We have to still do the thing where basically I'm going to iterate through this list and then, you know, determine how I should, if I should rotate or reverse, I guess reverse or rotate revrot. That's the thing. Everything. So for this first example, I think this is 1, 2, 3. Yep, that's our first chunk. So 1, 2. So this one was rotated, right? Or I mean reversed. So 9. Oh, excuse me. This one was reversed and rotated. Wow. Okay. Weird. Okay. So 9, 8, 7, 6, 5, 4. Whew. Okay. 9, 8, 7, 6, 5, 4. Interesting. Okay. Okay. And let's see, 9, 8, 7, 6, 5, 4. And that I have that in my output. And then the other one is 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Looks like I've got the same thing there. So this is pretty confirming. So this has chunks of 4 on that third one. Then this next 3 have the same chunk size. So the looks like that's a chunk size of 8. Yep, looks good. This next one's got a chunk size of 8, but it gives me nothing because it's an empty string. So that's interesting. That looks like that's good. Revrot. That's good, that's good. So those are the 0 ones, so those should be true. That one should also be working. So it occurs to me, you know, I can actually do this in an easier way. Every time I try to use error handling, I'm like, actually, I can kind of do this in an easier way that doesn't rely on error handling. So I think what I want to do is just put this, make this the edge case that it truly is, and just say, you know, because I know I'm only going to get this 0 division error if chunk size is 0. So I'm going to say if chunk size equals 0, and then I think or digit string equals empty string. In either of those cases, we're going to return empty string, so that feels a little cleaner. I don't know. And we've got a few more truths, right? So I'm just, you can see I'm just picking up all the easy, I'm going to just try to pick up all of the easy tests first, you know. So I can see in this case I've got a false and an empty list, and this is 1, 2, 3, 4 tests from the bottom. 1, 2, 3, 4. So it looks like we have a string of 4 elements and a chunk size of 5. So I think I can actually modify this condition. I need to even make this a little better. Let's just say if len of the digit string is less than, not less than or equal, but just less than chunk size. I think not. We should pick up that one there. So 1, 2, 3, 4. Oh. Where's that? I just like inserted a random character somewhere. Whatever. Okay, so that's that. 1, 2, 3, 4. There's that true, right? So I'm just picking up off all the easy ones first, right? And yeah, that's the great thing about tests, because it just makes your job easy. You know, you just go through it and you solve all the tests however you can, you know. So picking off all the easy ones first is no problem with that. And these are all just this edge case, just making sure that this edge case is gonna handle as much as it can, right? Because why not? So I know if chunk size equals 0, I definitely don't want to run this operation. I'll just return this. Or if the length of digit string is less than the chunk size, I can just return an empty string. I suppose the chunk size could be 0 and the string could be empty. So let's see about that. Let's mark this test. I'm just going to say mark. Just so we can see it. Mark, so this one actually is passing. So that's okay. Looks like that that case is handled. Oh yeah, because of course it is, because chunk size is 0. That makes sense. Okay, so is there a scenario if chunk size is 1 and this is an empty string, then it's less than 1. Chunk size is 1 and this is 1, then I guess we don't want to run this anyways. Okay, cool. Looks good. So, back to this. I think what I'm going to do is, since I've got all these passing from an edge case here, from my edge case, I'm just going to comment out all the ones that are passing. So that's going to be this one, and then, so that's that one. 1, 2, 3, 4, 5. 2, 3, 4, yeah. So should comment out these 4. Okay, and then the rest should be failing. Good. So I only want to, the only interesting ones are the ones that are failing. The ones that are passing we know are good to go, and unless we mess with this edge case or something, then they're just going to keep passing. So I can rely on those to continue to work. Okay. Cool. I'll fix those up. Now I'm gonna guess that what I have left over, I'm getting the right numbers in the list. Now it's just a matter of going through each of those lists, analyzing the number strings in there, doing the appropriate math and condition checking, rearranging them if necessary, and then after all that's done, combine the list of strings into a string and return it. Which is probably just gonna, we can actually do that part, I think, right now. Yeah, we can do that right now. That'll just be string.join list. Cool. So let's do the middle part then. I hope that's obvious too, right? Like, this is something that I see people struggle with. They're like, oh, when I get to that point, I'll need to do this thing. And, you know, it'll be an easy thing like this. And then I'll be like, okay, but I'll do that when I get there. If you know what it is, and it's relatively easy, just like get it down now, you can always work in the middle of the problem, you know? So it's not like writing a paper or something where, you know, I think that's writing a paper anymore these days is sort of an asynchronous task more and more, you know, because of computers, you know. But I think we tend to think of writing a paper as kind of starting at the top and then just writing and writing down, and then maybe doing rounds of edits on it, maybe deleting things, but, you know, sort of you're writing from top to bottom. With coding, like, you're writing everywhere. You're always working in the middle of something, you know. So it's fine to like work ahead a little bit. In this case, I think for debugging purposes, it's more interesting for me to actually see the list. So I am going to do this like this, but might as well write this line now. And then, actually, I'll do it like this. Then I have it there. Like, I already thought about it. I don't need to like reconstruct my thinking later when I get there, you know. Cool. Okay. Onward. So we'll say for chunk in list. Then what I want to do, I need to be able to do, there's some, I think it's the sum of the cubes. Okay. So if a chunk represents an integer such that the sum of the cubes of its digits is divisible by 2. So the sum of the cubes of the digits. Okay, so if the sum of the cubes of the digits. Okay, so I either gotta write a helper function. I think that's what I want to do. I'm just gonna write a helper function. I'm gonna call this def sum of the cubes of its digits. We'll just do this. Its purpose is only for this one thing, so we'll just do this. This is going to take in a digit string, and it will return the sum of the cubes of the digits. So I think I'm just going to return ACC equals 0, and we'll say for num in dgt stir if ACC plus equals int. We'll cast each num as an int num cubed. Okay, so a chunk represents an integer such that the sum of the cubes, so here's the sum part with the plus equals of the cubes, so that's going to be cubes, squares, cubes, right? So that's going to be this of the digits, which are this part here, is divisible by 2, reverse the chunk. Okay, cool. So sum of digit cubes. Let's do that. So I'm going to say if sum of digit cubes chunk mod 2 equals 0. Woo! And I think this is rev. That's the rev in revrot, I believe. Okay, so if the chunk represents an integer such that the sum of the cubes of its digits is divisible by 2, reverse the chunk. We'll do this. If the chunk represents an integer, this is weird. If the sum of the cubes of the digits in a chunk is divisible by 2, reverse the chunk. Okay, cool. We can do that. So we'll say let's just do another list here. Raw chunks. We'll call these raw chunks, and we'll iterate through raw chunks, and I'll say list equals empty list. So if the sum of digit cubes chunk mod 2 equals 0, then we'll reverse it. So this is what I'm going to do. I'm going to say chunk equals chunk, and I'm going to reverse it like that. That will give me the reverse version of it, and I think we can reverse and rotate. I think there's a case, because I believe this second chunk here was reversed and rotated. Nope, it was just rotated. I think it was this one that was reversed. So 3, 5, 6, 3, 5, 6. Okay. Otherwise, yeah, that tells me otherwise. So that's an else. Else rotate it to the left. So it's just an if or an else. Else rotate it to the left by 1 position. Put together these modified chunks and return the result as a string. Okay. So instead of chunk equals chunk like this, I'm just going to say list.append. List.append that. And then otherwise we want to rotate. So to rotate by 1, I think we just take the first number and put it on the end. So else it'll just be it'll be chunk sub 0 or chunk sliced at 1 to the end plus chunk sub 0. Whew. Okay. Well, we got an error, eh? Unbound local variable list, of course. So I changed that to raw chunks. Okay, all right. So let's just see what we've got here. And I might be able to get lucky here if I just do this. Oh, it looks like these are all passing now. Nice. So that works. So even though I was talking about like working ahead and just putting down something that you know ahead of time, I'm realizing this actually doesn't need to be a list. This could totally be a string accumulator. So let's call this res stir, and I'll just say like this. And instead of appending, of course, we can't append. We'll just plus equals like this. plus equals the result string. That kind of saves us something. Oops. Oh, that doesn't help at all. Okay, I forgot to actually make it a string. That's why. Cool. That looks like it passes all the tests there. Okay. All right. All right. So that's rev, and this is rotate. Okay. Oops. Weird. Okay. Cool. So from here, we could clean this solution up. I'm sure there are like cleaner, nicer solutions for this. But, well, you know what? Why not, huh? We've got just a little bit. We don't have time to do a whole nother problem. So we'll just go through this and clean it up directly. So I think one thing we could do is we could make raw chunks into a comprehension. I'll just do this as is tradition. Break out this append portion. We'll put that first. And then we'll put our loop head. Okay. We can do that there, and I think we can just do that like that. Of course, we could turn this back into... You know what? Let's run this. Make sure I didn't break anything. Let's make sure this actually is going to pass the tests first before we revise it. Let's do an attempt. Oh, hey, look at that. So we do have an exit code. Oh, because I didn't paste in my helper function. So that's just an error. A regular error. That's not a test failure, that's a regular error. Okay, cool. So it did pass all the tests. Okay. Great. So we'll try to see if we can get this down to a one-liner. So I have this. This is my raw chunks. I'm only using raw chunks in one place now, so it doesn't even need to be a variable. I am feeling very complicated about this code, but hey, why not? So we'll just put in the comprehension right there. We'll go back to making this a list for the sake of making it a comprehension. These were the things being appended to the list. So I think what we'll do is we'll turn this into a ternary, like this. Whew, okay, so there's our ternary. So that goes first. This goes second. I'll just cram that all into one line. We don't need raw chunks variable anymore. Oh my gosh, what a comprehension. This is the end of the loop head. Oh. And then now we're just doing all this. Of course, now we've got to join it. So I think I'll just try to join it right here. String.join. Like that. Let's see if it passes these tests. Looks like it does. So since, again, now I'm only using this variable in one place, so I can just return this. And now we took a nice readable solution and made it into a Code Wars friendly monster mega solution that is not that readable. Oh, I've got to get my helper function in there. Oh, what am I doing? Yeah, so let's make this a list. and we'll put this first, put this second. Get rid of the extra. And then of course we're just returning the sum of this, like that. And now since this is so small, we don't even need this helper function anymore. Oops. So we're doing that right here. So this is actually going to be, now I've got to be careful. That goes, so we're passing in chunk. Chunk gets represented as digit string. Okay, so I've got to use digit string right there. Okay, so now I'll just take this and pop it in like that. Now we don't need the helper function anymore. Whew. All right. This is just a lot of stuff right there. And then, you know, we've got this edge case. We could turn that into a ternary. If we do this, we'll say empty string if that condition, else that whole entire thing. Okay. So this is technically a one-line solution now. It's Code Wars compliant. That's a joke. I hope you're laughing hysterically because it was hilarious. It was a great joke. Okay, cool. Very, very good. All right. So let's attempt it. And it passed for some amazing, incredible reason. Let's submit it. Cool. Oh my gosh, this person made a lambda function inside the regular function. That is on another level. Cool. Cubes. People are making helper functions for this one. It makes sense. I mean, obviously I did it. Ah, see? So you always see interesting things, right? Somebody's importing from itertools import chain. I've never used that before, but chain.fromIterable. That's interesting. I don't know what that's about, but you can go look into it, and it's probably interesting. Probably an interesting way of solving that. Cool. All right, well, that's the Code Wars stream. Didn't get anybody asking questions today. That's all right. If you just want to hang out and watch me solve some problems, that's cool too. Yeah. So, you know, y'all let me know what you thought of the stream. If the quality's good, if the audio is okay. I'm hoping everything's kind of better than it's been audio and video wise. Yeah, just let me know your thoughts and any thoughts that you have for improvements. I'm open to suggestion. Just feel free to hit me up on Slack. Just DM me when you like, and I'll get back to you as soon as I can. I look forward to seeing you next time. Yeah, we'll just wrap up there. Cool. Bye-bye.